Okay, so moving on to unit 1.5, which is a catalog of essential functions. So these are the functions that you're supposed to know. So over here, I just have like the general families of functions that you're supposed to know. So number one, we have our linear functions, and a linear function is basically, okay, the normal equation that you usually deal with, y being equal to ax plus b, and for each and every family of this family of functions, you're supposed to know how to sketch them. So for a linear function, it's quite simple because it's just a straight line, and then you know that b is your intercept and a is your gradient, which becomes quite simple. And then we'll move on to the next one, which is power functions. So power functions are those functions which have y being equal to x to the power of n. So n can assume any value, but then you have to know which value n is assuming and how to plot it. Okay, so for example, if n is equal to 1, then your f of x is just equal to x. And then that is just a straight line, y being equal to x, which is quite simple enough. Then when n is equal to even numbers, so that's 2, 4, 6, 8, and so forth, meaning your f of x is equal to x squared, x to the power of 4, x to the power of 6, and so forth, you're going to have this kind of a graph. So for x squared, we already know that one. So it's just the simple parabola. Then for y being equal to x to the 4, it's almost the same shape as y is equal to x squared. But then as you go up over here, the gradient becomes steeper. So over here you see y is equal to x to the power of 4 comes over here, and then y to the x6 comes over here, which means y to the x to the power of 8 comes over there, x to the power of 10 there, and so forth. So it's just making the gradient larger. Okay, so moving on with when our n is an odd number, so that is starting from 3, 5, 7, 9, and so forth. So now you're going to have something like f of x being equal to x cubed, and then you have this sort of a graph. So x cubed, we know that one is this one, and then x5, just again the same, it's almost the same situation for your even and your odd. So as you can see over here, our gradient is becoming smaller and is becoming larger and larger. So this will be your y being equal to x to the power of 5, which means y being equal to x to the power of 7 would also do something like that. And what you have to know in both instances, your graphs intersect at x equal to 1 and x equal to -1. Okay, so I would like you to check for the graphs when your n is equal to -2, -4, -6, etc. So these are negative even numbers. And when they are negative odd numbers, so -1, -3, -5, and so forth, please do understand how to plot these graphs, because they're going to be essential throughout the whole course. So another form of power functions is when you have x to the power of 1 over n. So with that one, it's going to be represented by the square root. So over here, it's going to be f of x being equal to the nth root of x. So you can divide them into two divisions. So that's where you have your even and where you have odd. So you have 2, 4, 6. Those are your evens. You already know how to plot y being equal to the square root of x. It's just this one in blue, and then everything else is just comes below your square root. So the 4th root is below, which means your 6th root will be somewhere there, your 8th root, and so forth, going down and down and down. Okay, so it's the same situation for odd numbers. So like the cube root of x, but then now it will have both sides. So you have the negative and the positive for cube roots. For square roots, it's only the positive side. So you have the cube root over here, and then the 5th root is just below the cube root, same this side as well. So please take note of that, and those are your power functions. Okay, so moving on, we have polynomials. So polynomials, these are your general functions, like your f of x being equal to a n x to the power of n plus a n minus 1 x to the power of n minus 1 plus so forth and so forth up until you reach a1 to the power of x, a1 times x to the power of 1 plus a naught. So a basic example can be 2x squared plus 2x plus 1. So those will be your polynomials. But for it to be a polynomial, your a to the an, which is your coefficient of x to the power of n, is not equal to 0. It can be any other number apart from 0. And then you should know that a polynomial of degree n has at most n minus 1 turning points. So at turning points, we're talking about these points. For example, this one, that one, and that one. So those are called turning points. And then a polynomial of degree n has at most n x-intercepts. So at most, please take note of at most, because this whole graph might be shifted upwards, which means it might not even have any x-intercepts. Okay, so x-intercepts, it's where your graph crosses the your x is equal to 0 line, your y is equal to 0 line, I mean. So that's basically your x-axis. Okay, so this is what you need to know about polynomials. And then rational functions. Rational functions are just fractions of a polynomial over a polynomial. So a polynomial in your numerator and a polynomial in your denominator makes up rational functions. So, and what you have to know for rational functions, that the domain is all values of x apart from when your key of x is equal to 0. So you can get all real numbers apart for that instance where your key of x is equal to 0, since this whole fraction becomes indeterminate when key of x is equal to 0. Okay, so rational functions, normally they're used for, we normally deal with them when we're plotting graphs of functions, and they are known for having asymptotes. So you should be aware of that. And please go and look at them so that you can familiarize yourselves with the rational functions and how to plot them. Okay, moving on with exponential functions. So an exponential function is just a function where you have a number to the power of x, where that number is greater than 0. Okay, so please go and look at how they're plotted, because there are differences when your x, when your a is between 0 and 1, then the graph will be of a different shape. And then when your a is greater than 1, then it will also be of a different shape. So please do know how to distinguish them. Then logarithmic functions, so they're just called log functions in short. So these are represented by f of x being equal to log base a of x, and your base is always greater than 0, as well as your x as well. So your base is greater than 0, x is also greater than 0. And obviously you have to know the most basic one, which is log 1 is equal to 0, and be able to plot it. Trig functions. So trigonometric functions, we have 3 basic ones: sine x, cos, and the tan. So please know how to plot these, and then, because other trig functions are just a combination of these. So please do know how to plot these basic 3. And that will be it for theme 1.5. Moving on to unit 1.6, which is new functions from old functions. So basically, as the name says, we're developing new functions from the old functions that we already know. Okay, so the first part, suppose c is greater than 0. So c is just a constant greater than 0. And then we have y being equal to f of x plus c. So what this basically does, like adding that c, shifts the graphs shift the graph of y being equal to f of x, the one that you already know, by a distance c units upwards. So your graph basically moves c units upwards. And then if we have y being equal to f of x minus c, then we're basically shifting the graph of y is equal to f of x c units downwards. So these you're supposed to know. Okay, and then if now we put our c inside the bracket, so for example now we have y being equal to f of x minus c, then we're now shifting y is equal to f of x by c units to the right. So when it's horizontal shift, it's going to be y x minus c shifting to the right, and then when it's vertical shift, it's going to be plus c giving you upwards. And then f of x plus c, the c inside the bracket, then we're shifting y f of x by c units to the left. Okay, so for the next part, assume that c is greater than 1, so it's a constant greater than 1. Okay, so in this part we're basically shrinking and stretching, so stretching and compressing our graphs. So for example, if you multiply f of x by c, so it's y being equal to c f of x, then we're stretching the graph of y is equal to f of x vertically by a factor of c. And if we divide by c, so y being equal to 1 over c f of x, we are shrinking the graph vertically by a factor c. Okay, and y being equal to f of x, f of cx, that one shrinks y is equal to f of x horizontally by a factor c. And then y being equal to f of x over c stretches y is equal to f of x horizontally by a factor c. And then for reflections, we're going to be using -1. So if you multiply f of x by -1, then you're basically reflecting y is equal to f of x about the x-axis. And then if you have y being equal to f of -x, then we're reflecting y is equal to f of x about the y-axis. So these you must know by head, and the best way to do that is obviously through practice. Lastly, on 1.6 we have composite functions. So the basic definition of composite functions is, given two functions f and g, the composite function f of g, so this means f of g, is defined by f of g of x being equal to f of g of x. So you're basically taking g and where you had x is substituting with g of x. So I'm going to look at this example. It basically says, if f of x is equal to x squared and g of x is equal to sine x, find f of g of x and g of f of x. Okay, so f of g of x is given by f of g of x, that. Then that basically becomes f of sine x. So where we have x, we're substituting with sine of x. So that becomes, where we had our x was x squared, so we now have sine x squared, which is just sine squared x. And then g of f of x is just equal to g of f of x is our g of x squared, just sine of x squared. So it's basically sine x squared. Okay, so now I'm going to look at some questions from unit 1.6. Okay, so this is what we have. For the given functions f of g, f and g, determine f plus g, f minus g, f times g, f over g, f of g, and g of f. Okay, so our first function, our first set of functions is f of x being equal to 2x plus 5 and g of x being equal to x squared. So for f plus g, we have f plus g being equal to f of x plus g of x. So it's just 2x plus 5 plus x squared, which is x squared plus 2x plus 5. So that one is quite simple enough. You're just adding the two functions. Same as f minus g, you're just subtracting. So you have 2x plus 5 minus x squared. And then f times g, which is fg, is just equal to x squared factor of 2x plus 5. Just like that. And then f over g will be equal to 2x plus 5 over x squared. So with this one, you can even provide the domain and say that our x cannot be equal to 0, since when x is equal to 0, then we're going to have an indeterminate function. And then f of g is just equal to f of x squared is equal to 2 factor of x squared plus 5, which then gives you 2x squared plus 5. And then you do the same for g of f. G of f is just g of 2x plus 5, which basically makes 2x plus 5 squared. And then you're done with that question. So it's that simple. So just, I'm going to look at another one. And so the next one is exponent of x being equal to f of x and g of x being given by ln x. Okay, so f plus g is just equal to exponent of x plus ln x. F minus g is equal to exponent of x minus ln x. Then fg being equal to exponent of x times ln x. F over g being equal to exponent of x over ln x, and f of g being given by f of ln x, which is exponent of ln x. And then this can be further simplified, but then I'll only talk about it in theme 1.7 and 1.8. So for now, I'm just going to leave it like that. And then g of f is given by g of exponent of x, which is equal to ln exponent of x. This again can be simplified, but then for now we're going to leave it like this so that you just understand the concept that we're looking at right now. Lastly, we have f of x being equal to square root of x and g of x being equal to 2 to the power of x. Okay, so f plus g will be given by root x plus 2x. F minus g being equal to root x minus 2 to the x. F times g being equal to 2 to the x times root x. F over g being equal to root x over 2 to the x. Then f of g being equal to f of 2 to the x, which is equal to square root of 2 to the x. And then g of f will be given by g of root x, which is 2 to the root x. So you're just substituting where you had x, you substitute with what you have within the bracket, and then that will be it. So this is theme 1.6 we move on to theme 1.7. Moving on to unit 1.7, which is exponential functions. So an exponential function is a function which has this form, f of x being equal to a to the power of x, and your a is greater than 0. So we talked about these in theme 1.5. Then now we talk about them in depth. Okay, so basically if our a is greater than 1, then our exponential graph is going to be that, and it is known as exponential growth. So as you can see over here, our f of x values become larger and larger as we move towards x infinity. So that's why it's called exponential growth, because it's growing exponentially. And then if a is equal to 1, then we only have 1 to the power of x, and 1 to any power is just equal to 1. So we're going to have f of x being equal to 1, a straight line. Okay, and then when we have our a being between 0 and 1, then we're going to have exponential decay. So we're going to have that graph over there. So as x goes to infinity, our y values approach 0. Then they never go to 0. It's never equal to 0. So those are the three graphs that you have to know for our exponential functions. So please make sure that you understand when a is between 0 and 1, when a is greater than 1, and when h is equal to 1, and their respective graphs that you must plot. So moving on to properties of our exponential functions. So you actually notice from the graph that f at 0 is always equal to 1, and your f of x will never be equal to 0. Your f of x will always be greater than 0. So for all the exponential functions that you're going to have, you'll notice that your y values will never be less than 0, unless if you go like maybe your exponential function -2, then yeah, probably, because now you have a new function from an old function. Okay, and then the range is from 0 to infinity. Well, we said it's greater than 0, so it will always be 0 going upwards up until infinity. And then the domain is all real numbers. It can take any value of x. So an exponential function can take any value of x. So we have the number e, and that is called the natural exponent. And this number is approximately equal to 2.71828, and so forth and so forth. It's a recurring number. Okay, and then we have laws of exponents. Okay, so for laws of exponents, let's take a and b, which are positive numbers, and assume x and y are real numbers. Then, when you have a situation like that, a to the power of x plus y is equal to a to the x times a to the y. And then a to the power of x minus y is a to the x over a to the y. So whenever you have a negative over there, you know that it's 1 over that number. And then a to the x factor of to the power of y is just equal to ax times y. And then ab to the everything to the power of x means a to the power of x times b to the power of x. So that's all the theory from unit 1.7. Now we're going to look at some sample questions. Okay, so the question says simplify, and then it gives us some questions. So the first question is 3a to the power of 4 times b to the 3 times 2a cubed times b to the negative 2. Okay, so what I would advise you to do is group like terms together. So numbers on their own, symbols, same symbols like a on its own, and b's on their own. So it will be 3 times 2 times a to the 4 times a to the 3 times b to the 3 times b to the negative 2. Okay, so 3 times 2, that's 6a. So from our laws of logarithm, from our laws of exponents, I'm going to see that there's 4 plus 3, and then b is just 3 minus 2. which would give you 6a to the 7 b to the 1. So the 1 is unnecessary to write, so you just leave it as 6a to the power of 7 times b. Okay, the next one is the square root of 9x squared. Okay, so the square root is just equal to, let's say, the square root of y. So that's equal to y to the half. So basically what we have here is 9x squared, everything to the half, which from the laws translates to 9 to the half times x squared to the half. Then the square root of 9, we know that is 3, and then x squared to the power of a half is just x 2 times a half, which is 1. Therefore we're going to have 3x is our solution. Okay, the next question is, okay, it's ugly to look at, so to say, but then it's quite simple to solve. Well, what you're just going to do is group like terms together, and then it will be easier to simplify. So I'm going to put everything with x, y, and x and y. Okay, so for the numerator, it's going to be x 8n minus 3 times x. So this one, if you simplify, it's just going to have x negative 6n, and then times this x cubed as well, x3, so here it's minus. And then the y, it's y to the half times negative 6n, everything over x to the negative 4n times x to the negative 1 times n, so it's negative 1n, and then y is times y negative 4n, like that. And then I'm going to simplify. So on the numerator, it's going to be x 8n minus 6n, which is 2n, then minus 3 plus 3, that's just 0. So we're only left with x to the power of 2n, since x to the power of 0 is just equal to 1. And then times y, then half times negative 6n, that's going to be negative 3n, everything over x to the negative 4n minus n, it's going to be negative 5n, and then times y negative 4n. Okay, and then I'm going to write x is on their own and y is on their own, so it's going to be x to n. But then since it's over, it means minus, so it's going to be minus 5n, so it's basically minus negative 5n times y negative 3n minus negative 4n. And this then would be x 2n plus 5n, which is x to the power of 3n, times our y, negative 3n minus 4n, y to the power of n, like that. So the best thing to do would be to group like terms together, so it's your x is on their own and your y is on their own. Then you simplify from there onwards using the laws of exponents. Okay, the next question is 3 to the power of n, everything to the power of 1 minus n, over 6 to the power of negative 1 times 3 to the power of negative n minus 1, everything this side divided by 3 to the power of 1 minus n, everything to the power of n plus 1, over 2 to the power of negative 1 times 9 to the power of negative n minus 1. Okay, so it's the same situation. We're just going to do the same process, group like terms together, and it'll be easier like that. Okay, so this side, I'm going to first of all simplify over here. So that will be 3 to the power of n minus n squared over 2 do it like that over there. Then 6 to the negative 1. And then over here, we have a 3. So it's a 3 and a 3. So you're going to have minus negative n minus 1. And then that would give me 3 to the power of 2n minus n squared plus 1. Everything over 6 to the negative 1. And 6 to the negative 1 is just equal to 6. 1 over 6 to the negative 1 is just equal to 6. So this is 6 times 3 to the 2n minus n squared plus 1. Okay, so now looking at this other side, just going to first of all simplify it again. It's 3, and then that's 1 minus n, 1 plus n, so it will be n squared, negative n squared, plus 1 plus 1. And then over 2 to the negative 1 times, and 9 is just 3 squared, so it's 3 to the power of 2 factor of negative n minus 1. And then that, so 2 to the negative 1 over 2 to the negative 1 is just the same as 2. It's 2 times 3 negative n squared plus 1. And then this one, simplifying it, becomes times, okay, so I'm going to be subtracting, minus negative 2n minus 2. And this just becomes 2 times 3 negative n squared plus 2n, and then plus 3. Like that. Okay, so now to put it back in our original function, so just this one, so it's going to be 6 times 3 2n minus n squared plus 1 minus n squared plus 1 over 2 to the 3 negative n squared plus 2n plus 3. And then that will give us, so these two numbers can divide each other out, so that is 3 times 3 to the 2n minus n squared plus 1 minus negative n squared plus 2n plus 3. Okay, from here, this and that cancel out, that and that cancel out, then that's 1 minus 3, so that will be equal to 3 times 3, then 1 minus 3 is negative 2, then so that is just 3 to the 1 times 3 to the negative 2, which is just equal to 3 to the negative 1 is 1 over 3. Simple as that. Okay, so going back to the previous one, which was this one, I had made a mistake over here. Okay, so I'd say 3n because I'd say 2n minus 5n, but then it's supposed to be 7 over there. It's supposed to be 7 because it's 2n plus 5n giving you 7n. Okay, so just please take note of that correction. Lastly, we have 3y everything to the power of negative 2 divided by 3y negative 2 everything to the power of 2 over 3. Okay, so with this one, first of all, simplify the numerator. And we have 3 negative 2 and y negative 2 over 3 y negative 2 everything to the power of 2 over 3, like that. Okay, and from here you see that the y's are going to cancel out. It's a common factor. Then you're going to be left with 3 negative 2 over 3 to the 1. Okay, so this becomes 3 negative 2 minus 1 to the power of 2 over 3, because we're removing the denominator to put it on the numerator as well. So that will be just 3 negative 3 to the power of negative 3 over 2 over 3, which is equal to 3 negative 3 times 2 over 3. Then those 3 cancel out. You're going to have 3 to the negative 2 just equal to 1 over 3 squared is equal to 1 over 9. So with these exponents, you just have to group like terms together, simplify using the laws of exponents, and then you will be done.